Hello everyone, welcome back to my channel. So today again we are going to solve an issue related to facility identification. So basically we are going to find a suitable location where we can set up our plant or facility for the production so that we can minimize our transportation cost. So we'll read out the problem statements first of all. We will build a mathematical model and finally we will solve the issue by using the Excel solver. So let me share my screen. Okay, so I hope that you are able to see my Excel file. And this is our problem statements today. So basically we have 5 markets. And what are those 5 markets? USA, Brazil, Denmark, UAE, and Vietnam. These are our 5 markets. And we have 5 sources. What are the 5 sources? USA, Brazil, Denmark, UAE, and Vietnam. Okay. To transfer the materials from USA to USA market, we have to spend 50 rupees per piece. So to transfer a material made in USA to the USA market, on an average, we have to spend around 50 rupees per piece. Similarly, to transfer the material from Brazil to USA, to transfer a piece of material made in Brazil to USA market, we have to spend around 70 rupees per piece. Okay. If we set up a plant in USA, then fixed cost capex will be 6 million. That means we need to spend around 6 million rupees if we set up the plant or facility in USA. If we set up that plant or facility in Denmark, our one-time expense will be 7 million. Okay. For UAE, that will be 4 million. For Vietnam, that will be 3.5 million. Okay. Now, also the production capacity of each plant we have mentioned. So this is the production capacity of each of the plants. So for an example, if we set up the plant in USA, if we set up the facility in USA, we can able to generate a production capacity of 20 pieces from that USA plant per day. Okay. So for Brazil also, it's 20 pieces per day if we set up that facility or plant in Brazil. Okay, now we need to find out that where we can set up the facility for production. So as I said earlier, basically we are going to find it out where we can set up this facility or the plant so that we can able to cater these 5 markets with minimum transportation cost so that we can meet the demand of these 5 markets. So what are the demands of these 5 markets? For USA market, we have a demand of 12. For Brazil, we have a demand of 6 piece. For Denmark, we have a demand of 14 piece. Let's consider this demand per day. Okay. UAE is 16 and for Vietnam, that is 7. So that we can able to meet the demand of these 5 markets using minimum transportation cost. So we have to decide where we can set up our plant or facility from these 5 sources so that we can able to cater or fulfill the demand of these 5 markets, but keep our transportation cost in a minimum amount. So basically, we want to fulfill the demand of these 5 markets by setting up a facility using minimum transportation cost. So we need to consider all these input parameters to decide where we can set up our facility or the plant. And what is mentioned in the last line, maximum 1 facility we can set up in each location. That means if we decide that we need to set up the plant in USA, the maximum facility or plant that we can set up in USA is 1. So that is applicable for all the other 4 sources as well. Brazil, Denmark, UAE, and Vietnam. So if I summarize, basically, we need to find out where to locate the facilities. Okay. And second thing we need to find out how much quantity we need to transport and from where. Okay, so these two things we need to find out by considering all these input parameters and the constraints. Right? Okay, now let me delete this one. So I am just copying the entire table to here. Okay. And I am changing this one as yi. Now, what is yi? Yi is basically the location variables. Yi is basically the location variables. Okay. So here we are going to find out that where we need to set up the plant or the facility to cater the demand of this market, considering all the input parameters and the constraint. So this becomes one of our decision variable. So this becomes one of our decision variables. And if you see in the last line, we have mentioned maximum one facility we can set up in each location. That means we can say the values of yi is binary. Is binary. Why? Because we have mentioned only one facility is possible in a given source. So yi can be only 0 or 1. That is why it's a binary variable. Okay. So let me these statements and let me write it down here. Location variables. Okay. Now, if you can able to recall our last transportation model, what I have discussed is xij equals to quantity that we transport from source I to destination j, right? Quantity that we transport from source I to destination j. So source equals to I, source equals to I, and destination equals to j. We can say here source equals to I, destination equals to j. So as per this given problem, we can say we have 5 sources, which is USA, Brazil, Denmark, UAE, and Vietnam. And we have 5 destinations of the markets. Destinations of the markets. These are the 5 destinations: USA, Brazil, Denmark, UAE, and Vietnam. Okay. Now, the quantity that we are going to transport from USA to USA 1 market, that becomes our xij. So this becomes our xij. Xij. That means we can say that this is x. This is x11. The first one is for what? The first one is the source, and the second one is the destination. So for this column, we can refer this as X12. What is 1? 1 stands for the source, that is USA, and 2 stands for the destination, that is Brazil. Similarly, for this one, it will be X13. This will be X14. And this will be X15. So remember the Xij. Remember this Xij. I equals to source. J is the destination. Here X15. 1 stands for the source and 5 stands for the destination, that is Vietnam. Okay. Similarly, here we can mention X21. 2 is the source, that is Brazil, and 1 is what? 1 is the destination. X22, X23, X24, X25. Okay. Similarly, here we can mention X31. For this one, we can mention X41, and this is X51, right? So 5 is what? That is the source Vietnam, and 1 is what? That is the market USA. So if we want to now implement the mathematical model, so let's first of all implement the demand constraint. Okay. So as per the problem statement, we have to meet the demand of these 5 markets. So what are the demand of these 5 markets? These are the demands. For USA market, we have a demand of 12. For Brazil, it's 6. For Denmark, I am just ignoring this 1000 units as of now. Okay. UAE is 16 and the Vietnam is 7. So this is what, this is the, let me delete these things. So these are what? These are the quantity that we are going to transport from the source to the destination. That means we can say that means we can say for demand constraint X, this is what? This is 11, X11 plus this is what? X21, X21. 2 is source 2, that is Brazil, and this market is what? Destination, that is USA. That is why 21 plus for this one that will be X31. For this one that will be X41 plus X51. The last one is X51, needs to be equal to how much? 12, right? So this one we have implemented only for the USA market. Now we need to do the same thing for Brazil, Denmark, UAE, and Vietnam markets as well. So how we can write those things? So again, X, this column is what? X12, right? Plus X, this is what? 22 plus X, this is 32. This is 42. X52 should be equal to how much? 6. That is the demand of the Brazil market. Okay, now for Denmark, we can write X13 plus X23 plus X33. Which one is 33? This one, right? Plus 43. Five three equals to how much? 14. Because that's the demand. So similarly, we need to write it for UAE and Vietnam as well. Okay, so if you see here, our sources are changing. Which is the source? This is the source. This is the source. This is the source. This is the source, and this is the source. So our sources are changing, but our destination remains same. So destination here is 1. This is also 1, 1, 1, 1. So last time we have discussed, instead of implementing the mathematical method like this way, we can write a compact mathematical model. So how to write a compact mathematical model? So for demand constraint, the compact mathematical model will be summation. So here I have already mentioned that our source is changing from 1 to 2 to 3 to 4 to 5. So that means we have 5 source. So here we can mention I equals to 1, 2, I equals to 5. Because our sources are changing from 1 to 2 to 3 to 4 to 5, that means we are doing a addition of all these sources. So that is why I have mentioned here I equals to 1 and I equals to 5, and this is summation. Summation is nothing but the addition. Now Xij. Here we need to mention Xij. What is Xij? Again, the quantity that we are transporting from source I to j location, that is Xij, equal to dj. Now what is dj? What is dj? dj equals to demand at jth market. That is why we have mentioned here equal to 12, 6, and 14. What are 12, 6, and 14? 12 is the demand for USA market. 6 is the demand for Brazil market. And 14 is the demand for Denmark market. So we can mention here summation I equals to 1, I equals to 5, Xij equals to dj. So this becomes our compact mathematical model for demand constraint. Okay. Now, if we want to repeat this formula for all the jet market, then we need to write, because this formula is applicable to all the jet market, right? You can see here, this is applicable to all the jet market. So what we need to do, we can mention again the summation. Okay, let me just delete here. Okay, so for the compact mathematical model, we can write summation I equals to 1, I equals to 5, xij equals to dj. And as this formula is applicable to all the jet market, we need to apply, or we need to write, this is applicable for all set of jet market. Okay, so capital J is nothing but the set of small j. So small j consists of markets like 1, 2, 3, and j, set of j means capital J means set of small j. So set of small j means it consists of value 0, 1, 2, 3, like this way. Okay, so this becomes our compact mathematical formula for demand constraint. So this is for demand. So this formula is also correct. This formula is also correct, but instead of writing all these things one by one, we can just simply write the formula like this way, and it looks very much compact, and you can able to conclude your mathematical model in a more faster and more compact way. Okay, so demand constant we have discussed. Now okay, now what is our objective? So our objective again to minimize the cost. And here we have two different type of cost. Okay, so here we have two different type of cost. One is capex cost. This is one-time cost to set up a plant at a given location. Okay, so this one we have already discussed, that if we want to set up a plant in USA, one-time investment that we need to make is $6 million rupees. Okay, so this becomes our capex cost, and this is a one-time cost. And second one is the opex, that is the operation cost. So operation expenses are like whenever we are transporting any material from a facility to the market, definitely we have to pay something. Okay, so in our problem, to transport a piece of material from USA plant to USA market, we have to spend around 50 rupees. And if we want to transport the material from Brazil facility to USA market, we have to spend around 70 rupees per piece. So this becomes our OPEX. Okay, that means we can say we have a fixed cost and we have variable cost. The variable cost is nothing but the OPEX, the operation cost. Okay, so if we need to write a mathematical formula, we can mention like this way. For fixed cost, it is $6 million Y1 plus 4.5 million Y2 plus 7,000 Y3 plus 4,000 Y4 plus 1,500 Y5. So this becomes our mathematical formula for fixed cost. Now what is Y1? So this is Y1. This is Y1. This is Y2. This is Y3, Y4, and Y5. So why I have mentioned like this way? Now look, see, we need to spend around 6 million if we set up the cost at Y1, that is USA. Okay, we have to spend around 4.5 million if we set up the facility or plant at Brazil, that is Y2. So that is why I have mentioned like this way: 6,000 Y1 plus 4,000 4,500 Y2 plus 7,000 Y3 plus 4,000 Y5 plus 3,500 Y5. So this becomes our fixed cost mathematical model. Now what about the variable cost? So again, variable cost will be huge. That will be 50 x11 plus 70 x12 plus 100 x13 plus 120 x14 plus 100 x15 plus 70 x21, like this way. So basically variable cost I have started from here. 50, that is the amount that we need to spend if we transport any quantity from USA plant to USA market. Okay, so that is why I have mentioned here 50 x11. 11 means what? Source and destination. So this is source 1, destination 1. If we consider this thing, then this is source 1, that is USA, but destination is 2, that is Brazil. That is why I have mentioned here 70 x12. Similarly for this one, 100, source 1, but destination is 3. So that is why I have mentioned here 100 x13. You can see here 100 x13. Then 120 x14. This is 100 x15. Okay. The next one is 70 x21. 21 means what? 2 means source, that is Brazil. Destination is 1, that is USA market. This one we can consider 50 x22. 50x22 means what? 22 means 2 is for source Brazil, and this one 2 means what? The market Brazil. So that is why we need to mention here 50x22. So from here we need to go up to this level. Okay, so this becomes a huge formula. If we consider the last, then we can mention 70x 55. So 70x55 means what? This one, Vietnam, that is source number 5, and to Vietnam market, that is also destination number 5. So that is why we have mentioned here 70x55. So like this way, we need to go from here up to this level to build the mathematical model for the variable cost. So what will be the total cost? The total cost will be fixed cost plus variable cost. So that becomes our objective. Okay. So if we build a mathematical model in a more compact way, then we can mention summation I equals to 1. I equals to 5. Fi. Yi. So this part becomes our fixed cost. So this is our fixed cost. What is Fi? Fi equals to fixed cost for having a plan at ith location. And Yi, I already told you, the location variable. Okay, so Fi, that is the fixed cost. So fixed cost is what? 6,000, 4,500, 7,000. So this becomes our fixed cost. And Yi is the location variable where we want to set up the plan. From there only, we are going to consider the cost. For an example, if we set up the plant in USA, then only we are going to consider the cost of that capex, right? Means if we do not want to set up the facility in USA, then definitely we are not going to consider this cost in our objective function. Okay, so if we set up the plant in YI location, then only we are going to consider the fixed cost for that specific location. Okay, so this becomes our compact mathematical model for the fixed cost. Now for the operation cost, what we can mention? So that becomes our summation. Fixed cost plus variable cost, that becomes our objective. So for operation cost, again, we need to mention the same thing. I equals to 1. I equals to 5. And J equals to 1 because we have 5 markets and 5 destination. J equals to 5. Cij and Xij. Now what is Cij? What is Cij? It's the variable cost per unit for transporting the material from I location to J market. So that is basically the variable cost. So what is the variable cost? 50. If we transport any material from location I, from I location means what? From USA to the market USA. So I have mentioned the same thing here. Okay. And Xij that I have already mentioned earlier. Xij is nothing but the quantity that we are going to transport from location I to J. And Cij is what? The cost that we are going to spend to transport that material from location I to destination J or the market J. So this formula becomes our variable cost. Okay. So this entire formula will be our mathematical model for objective function. So instead of writing so much big formula, we can just write the mathematical model in a much more compact way. Okay, now we have understood about the demand constraint. We have also understood the mathematical model of the objective. Now let's discuss about supply constraint. Okay. Supply constraint. Now, here you can see what is the production capacity. If we set up a plant in USA, the production capacity of that plant will be 20 pieces. If we set up the facility of the plant in Brazil, the production capacity will be 20. So that means we can say, if we want to build a mathematical model, we can say x11 plus x12 plus x13 plus x14 plus x15 should be less than equals to how much? 20y1. So this model or this statements I have written for this line. Okay. So this is x11, source 1, destination 1. So that is why this is x11. This is x12, source 1, but destination is 2, that is Brazil. This is x13. This is x14. 1 means USA, 4 means UAE, the destination, and this is 15. So x11 plus x12 plus x13 plus x14 plus x15 should be less than equals to 20y1. So 20 is what? That is the production capacity if we set up the plant in USA. Okay. And why y1? Y1 means what? If we only set up that facility in USA, this statement is correct. Otherwise, if we do not set up the facility in USA, then definitely we are not going to supply anything from the USA plant. So yi is what? Yi is our location variable. So that is why I have mentioned here y1. If we only set up the plant in USA, then only this statement is correct. Otherwise, if we do not set up the plant in USA, then definitely the production capacity will be 0 for us. We are not going to supply anything from the USA. Okay. So like that way, we can mention for this line also, the second line also. So again, that becomes x to 1 plus x to 2 plus x to 3 plus x to 4 plus x to 5 should be less than how much? 20y2. Okay. So like this way, we need to mention for Denmark, for UAE, for Vietnam as well. So if I write down for Vietnam, so that becomes our x 51 plus x 52 x 53 plus x 54 55 less than equals to how much? 20y5. So here you can see our source remains constant. What is the source? 55555. Our source remains constant, but our destination is changing from 1 to 2 to 3 to 4 to 5. So if we want to write the supply constraint in a more compact way, then we can mention summation j is nothing but the destination. So j starting from 1. So this is j starting from 1 equals to j up to 5. Okay. 1, 2, 3, 4, 5. So that means we can mention here summation j equals to 1, j equals to 5, xij. Xij means what? The quantity that we are going to transport from source to destination should be less than equals to how much? Xi. Yi. Now what is Xi? What is Xi? Capacity of source. Okay. So Xi is nothing but the capacity of the source. This is the capacity of the source. Multiply with the facility location. So this is only applicable if we set up that facility at that particular location. Okay. And if we want to implement this formula for all the jth market, then again we need to mention the same thing. This is applicable for all I set of I. So this supply formula is applicable to all the source. Okay. So this becomes our compact mathematical model for the supply constraint. All right. So I hope that as of now, whatever we have discussed about this problem and how we build the mathematical model, first of all in a generic way and then in a much more compact way, now you have a basic understanding that how we can formulate any problem language or how we can formulate or how we can change the English language in a mathematical model, and that is also in a more compact way. Okay. So now we are going to solve this issue by using the Excel solver. Okay. So whatever we have discussed or whatever we build a mathematical model. Okay. So for demand, obviously we can mention this one. That will be summation. Okay. So this is summation of what? The quantity that we are going to transfer from all of these sources to the USA market. So that becomes our demand. Okay. And this becomes our DV. So basically we are going to find out two different things where to set up the facility and how much quantity to transport and from where. So these two things we need to find it out by using the Excel server. So this becomes our decision variables. Okay. Now total transported. So this will be the summation of all these 5 markets. What we have, what we are transporting. And there will be one another thing. Total capacity. So total capacity is what? Only if we set up that plant or facility at that particular location, then only we can able to supply the material from that facility. Okay. So how we are going to determine the total capacity? This one, multiply with the production capacity. Okay. So if we set up the plant, suppose for an example in USA, then only our capacity will become 20. But if we decide that no, we are not going to set up any plant at USA, then the total capacity for the USA plant will definitely needs to be 0. So that is what I have mentioned here. Okay. You can do the testing for Brazil as well. If we decide to set up the plant in Brazil, then only we can able to supply the material from Brazil. And what is the total capacity of that Brazil plant? The total capacity of the Brazil plant needs to be 20. And what will be our objective formula? So we discussed during our mathematical model, we have two different type of costs, right? One is variable cost and one is fixed cost. So what will be our fixed cost? Fixed cost is some product, comma, this one. So this is our fixed cost. So if we decide only to set up that particular plant at a given location, then only we are going to spend that fixed cost amount. Otherwise, we are not going to spend any penny related to the fixed cost. So that is what I have mentioned here, some product. This one multiplied with the fixed cost. Okay. And what will be our variable cost? So again, we are going to use the sum product. This is our cost. And this will be our quantity. Okay. And what will be our total cost? The total cost will be fixed cost plus variable cost. Okay. So more or less, I have formulated the formula. Now let's go to the data. Go to solver. Reset all. Where is our objective function? This is the objective function. So that will be mean or max. That will be mean only because we are going to find it out the minimum cost to set up the plant and to fulfill the demand of these 5 markets. So we need to find out the minimum cost. What will be our variables? This will be our variables. All the quantity that we are going to transport and where we are going to set up our plant. So these things will be our decision variables. Okay, now constraint. What are the constraint? So demand needs to be fulfilled. So that is why I have mentioned these things equal to these things. Okay. And for supply, total transported quantity needs to be less than equal to total capacity. We cannot supply anything more than total capacity. Okay. And there is one another constraint. Maximum one facility we can set up in each location. That means we can say this cell is a binary that we have already discussed earlier, that only 0 or 1 is applicable. Okay. So I just selected this column and binary. Okay. Now make unconstant variables non-negative. Take this option if we do not want any type of negative quantity to be transported from any one of these sources to any one of these markets. So if we want only the positive quantities or the values, then please keep this option as a ticked. Okay. And as this is a linear problem, again, we are going to use the same solving method, that is simplex LP. Now click on solve. Keep on. Okay. Okay, so we got our result. And ignore this one. Okay, so this is to the power minus 60. So you can consider it as a 0 only. So by manually, I'm just changing it to 0. Okay. So here you can see we have fulfilled all the demand of these 5 markets. What are those demands? 12, 6, 14, 16, and 17. So we have fulfilled all the demands. This is the quantity that we are going to transport. And these are the locations where we are going to set up our plant. So basically, we are going to set up our plant in 3 locations. One plant we are going to set up in Brazil, one plant we are going to set up in UAE, and one plant we are going to set up in Vietnam. Okay. And the materials that we are going to supply from Brazil facility, we are going to supply mainly to USA market and then to Brazil and Denmark. From UAE facility, we are going to send the materials to the UAE market and to Denmark market. The plant which we are going to set up in Vietnam, from there only we are going to cater the markets of Vietnam and Denmark. Okay, so here also you can see we have fulfilled the supply constraint as well. Okay, so we are not supplying anything more above of our capacity of the plant. And if we follow this plan, then our cost will be around 16,470. And this is the best optimal solution by considering all the input parameters and the constraint that we have mentioned in our problem. Okay. All right. So I hope that you have enjoyed today's class. So today we have introduced some new concepts like CapEx and OpEx, and we have found out that where to set up the plant or the facility, considering that you have to minimize the transportation cost and also you have to fulfill the demands of the markets. Okay, so this is a problem related to strategic decisions. And as we progress further, definitely we are going to increase our complexity of the problems. So stay tuned and thanks for watching.